I'd like to look at a second example of grouping in pairs. This one's a little bit more straightforward, and it's not going to have this messy thing at the end that we need another method for. So here we have 7p cubed q squared plus 21p squared q squared plus 6pq cubed plus 18q cubed. Now, again, with any grouping in pairs, I'm going to treat each pair of terms as a separate factorization problem. Looking at this one, the highest common factor of the coefficients is going to be 7, and of the pronumerals, there's a p squared and a q squared in each one. Then I'm going to get a p from the first one, and from the second I'm going to get a 3. Alright, this second set of terms, there is going to be a common factor of 6q cubed, a p plus 3. And as with any grouping in pairs problem, the second brackets will always be the same because we'll rig the question so that happens. So of these two terms, there's a p plus 3 in common. So I'm going to factorize that out the front, and I'm left with 7p squared q squared plus 6q cubed. Now, I've completed the grouping in pairs. However, some of you might have noticed that there's actually something that I forgot to do. I can tell that I forgot to do something because I look at this second bracket and I notice that there's actually a common factor there. Both terms have at least a q squared in them. Okay, this one's got a q squared, that's got a q cubed. And if this happens, it means you didn't try to do a highest common factor first. And in fact, if you look at this first step, oh, I've lost the bottom of my line of working, but if you look at that first step, you'll notice there is a q squared in every term. Now, it's not the end of the world. I don't have to redo the whole question. It just makes it a little bit trickier at the end if you forget to do that factorizing. What I need to do is I'm going to just rewrite that p plus 3. I'm going to leave that unchanged for the moment. I'm going to have to do a highest common factor on this bracket. Okay, and looking here, there's actually a q squared in both terms, so I can actually pull that q squared out the front. Now I could write it here like this, but it's weird to have that q squared in the middle there. Normally we put the individual terms out the front and anything in brackets comes after. So it's actually better to write it as q squared out the front, p plus 3, and then the final bracket 7p squared plus 6q. And this is the best way to write our final answer. The q squared out the front, p plus 3, 7p squared plus 6q. And this is the furthest that we can go with factorization. This cannot be factorized any further.